Good morning/afternoon, everyone. I'm excited to welcome you to today's presentation on equivalence-based instruction. We'll be diving into the foundations of this approach, exploring effective strategies, and looking at practical applications. Our focus will be on how stimulus equivalence can boost learning efficiency, promote generalization, and ultimately improve educational outcomes. Let's get started. Equivalence-based instruction, or EBI, is a teaching method that uses the idea of stimulus equivalence to help learners acquire new knowledge. Essentially, stimulus equivalence means that once a learner understands certain relationships between stimuli, those stimuli can become interchangeable in how they respond. This is a powerful concept in learning theory and behavior analysis because it shows us how new connections can emerge without the need for direct teaching of every single relation. In practical terms, EBI is valuable in education and training because it allows learners to acquire complex skills more efficiently, promotes better generalization of what's been learned, and cuts down on the time required for instruction by tapping into these underlying relational networks. These benefits make EBI an important approach for effective and streamlined learning. Let's delve into the three key properties that define equivalence relations. First, we have reflexivity, which is simply the idea that every stimulus is equivalent to itself. Think of it as a baseline. A equals A. This is fundamental because it establishes self-identity in the relation. Next is symmetry, which means if a stimulus A is related to stimulus B, then B must also be related to A. In more practical terms, especially in education, this shows up when a student understands that the written word and the spoken word represent the same concept. The relationship goes both ways, reinforcing learning. Finally, there's transitivity. This is where things get interesting. If A is related to B and B is related to C, then A must be related to C. This creates a network of linked stimuli, allowing for broader comprehension and generalization. It's through these connections that we build complex understanding by relating new concepts through familiar ones. An equivalence class refers to a set of stimuli that a learner perceives as interchangeable because of the relationships they've learned between those stimuli. For instance, consider the printed word dog, a picture of a dog, and the spoken word dog. Even though these are different forms, they can all be grouped into one equivalence class because the learner understands they all represent the same concept. This grouping is powerful in learning since it promotes stimulus generalization. It means that once the learner has been trained on one membered class, they can respond correctly to other related stimuli without explicit training. This not only saves time, but also enhances cognitive flexibility, allowing the learner to apply their knowledge more broadly and efficiently. In this slide, we focus on establishing equivalence through conditional discrimination. First, conditional discrimination procedures are essential because they train learners to respond differently depending on the specific conditions or contexts. Next, it's important to systematically reinforce correct responses to certain stimulus pairs. This reinforcement helps learners start to form connections or equivalence relations between those stimuli. For instance, we might teach someone to match spoken words to pictures, and then pictures to printed words. Over time, this process creates a strong link among all three: the spoken word, the image, and the printed word. Finally, once this training is in place, we can observe untrained matches occurring naturally, confirming that true stimulus equivalence has been established. This approach is powerful in helping learners generalize and integrate information across different forms. Derived relations happen when learners show responses to stimulus connections that they haven't been directly taught, but that naturally emerge from previous equivalence relations they've learned. This ability is really powerful because it helps make learning more efficient. Learners don't need to be taught every single possible pairing explicitly. Instead, they can generalize from what they already know. This has a big impact in educational settings, as it encourages rapid generalization, allowing learners to apply their knowledge flexibly across various contexts or different stimuli, without needing extra instruction. Essentially, it makes learning more adaptable and effective. When we talk about instructional strategies using equivalence-based instruction, one key approach is structured matching to sample tasks. These involve teaching conditional discriminations that help students form equivalence classes, which is crucial for understanding relationships between concepts. In language teaching, for example, This strategy can be used to connect spoken words with their written forms and corresponding pictures. This approach not only builds vocabulary, but also strengthens a learner's ability to generalize and apply language skills in different contexts. Equivalence-based instruction also plays a significant role in special education. It supports learners with disabilities by helping them form critical cognitive connections, making communication and learning more accessible and effective. Overall, the focus here is on teaching relations between stimuli rather than isolated facts. This emphasis leads to learning that is more durable, meaningful, and transferable across different situations, enhancing the overall educational experience. Now, let's look at some real-world applications of equivalence-based instruction. First, in language acquisition, this approach helps learners pick up vocabulary and syntax more effectively by combining different types of stimuli, like words, pictures, and sounds. This integration really boosts understanding and retention. Next, in the context of autism and disability interventions, equivalence-based instruction plays a crucial role in developing communication skills and adaptive behaviors, making daily interactions and learning more accessible. Finally, when it comes to cognitive and behavioral training, this method enhances problem solving and relational reasoning skills, helping individuals think more flexibly and make connections between concepts. These applications highlight the versatility and impact of equivalence-based instruction across various fields. When we look at the benefits of equivalence-based instruction, one major advantage is how it promotes generalization. This means learners can apply what they've learned across different settings and with various stimuli, not just in the specific situations where they were taught. Another key benefit is that EBI can reduce the teaching load. Because it leverages derived relations, it minimizes the need for direct training on every single item, making instruction more efficient. On the other hand, there are some challenges we need to be mindful of. Designing EBI requires careful planning and ongoing assessment to make sure that equivalence classes are formed correctly. If they're not, the instruction won't be effective. Additionally, learners can respond quite differently to EBI, so it's important to individualize teaching approaches to meet each learner's unique needs. Balancing these benefits and challenges is crucial for successful implementation. To summarize, we've covered the foundational concepts of equivalence-based instruction, including key ideas like equivalence relations, equivalence classes, and the use of conditional discrimination procedures. One of the main benefits of EBI is that it facilitates derived relations, which significantly improve generalization and make learning more efficient. We've also seen how EBI applies in real-world settings, especially in language education and interventions for special needs. Looking ahead, future research is likely to focus on developing new instructional technologies and personalized approaches to maximize EBI's effectiveness. Ongoing investigation will not only refine these methods, but also reveal new ways to integrate equivalence principles into educational practice.